Hello, Precalculus student. This video is for chapter 3.7, part 5. I forgot what part we are, but we're going to talk about application of rational functions. So there's two work problems that we're going to go over. So normally, a rational function shows up when there is a denominator in the expression. And so when this happens, you wonder what happens when the input goes to infinity, especially when time is the input. So that means what happens when this particular function goes on forever, like when time approaches infinity in the long run. So when you use it to model rate or model profit or model concentration of a particular chemical in the bloodstream, so this is an example. C of T is the concentration of a certain dosage of a medication, and is 0.7T plus 900 over 4T plus 5 when for T greater than or equal to 10. So after 10 hours, so you can use this function to calculate the concentration of that particular medication. What is the concentration at time equal to 10? So we can plug in. Just see C of 10, right? C of 10 will be 0.7 times 10 plus 900 over 4 times 10 plus 5. So put in the calculator. So the top would be 907, 900 times 7. And the denominator would be 45, right? So that would be 907 divided by 45. That is 20. Let's say round to 2 decimal places, 16 parts per million, right? That's the dosage. What would the concentration approach as time elapses infinitely? So when time approaches infinity, that is the end behavior, right? We're talking about end behavior. So we would need to look at the degree of the numerator and the denominator of the functions because they're both approaching infinity. And because the degree is the same, right? So degree of the numerator is degree 1. Degree of the denominator is also degree 1. So degree is power, 1 and 1. So the horizontal asymptote would be C is equal to 0.7 over 4, the leading coefficients, ratio of the leading coefficient, so it will be 7 over 40, 0.175. So it would drop. So from 10, it will be 20, all the way drop to 0.175 parts per million in the long run. So that's one use of it. So if you see any model that have a numerator and denominator, you can use this to figure out the long-term value of that function. Example 2 is to model volume. Okay, there is an open box, that means no top, with a square base. The side length is x. So this box has a base that is a square, so that means x. But we don't know the height, right? Let's say the height is y. So the volume is x squared y, but we know that the given volume is 62.5. So this is what we have. This is the facts that is given, right? All these are given. Now we want to write surface area. So we need another function as a surface area of this box. Because there is open box, there's only one top, so the surface area will be the bottom square, which is x squared, plus the four side, 4 times x times y. So this is the surface area, but it involves a y function or a variable. In the requirement, we are to write the surface area as a function of x only. So I need to replace y. So where can I do? Oh, we actually know that v is 62.5 is equal to x squared y. So we would use x squared y equal to 62.5 to solve for y. Y would be 62.5 over x squared. Okay, and so this would be x squared plus 4x times 62.5 over x squared. X and x squared cancel. Will become 4 times 62.5 is what? 4 times 62.5 is 250. X divided by x squared is x only, right? Cancel one x. So this is the function. What is the domain of this function? So we know that x is in the denominator. You cannot be 0. And x is a length. It cannot be negative, so it must be positive. So the domain would be x is 0 to infinity. Domains means what the allowable x value is. We don't need to know what is possible, but we just need to know what is the answer, but this is just the domain. Now use the calculator to find the dimension of the box so that the surface area is in the minimum. So SA is the function. It has to be equal to x squared plus 250 over x. So if you have different value of x, the surface area is different. So let's use decimal. Okay, so we would say y is equal to, what was it, x squared plus 250 over x. Okay, cancel this first. So this is our function. We don't see, we see the term here. Okay, so we only look at the positive side because the negative side is not, this one is not allowed. So on this side, the lowest point is when x is equal to 5, y is equal to 75. So the lowest surface area is at 10 when x is equal to 5. And x equal to 5, SA will have a minimum. Because at x greater than 0, this is the lowest number. Of course, when x is less than 0, there are other numbers that's lower than 75, but this is not in our domain, so we are only looking at this side. So that's all for 3.7.